Good morning. Today we want to look at number basis. What do we mean by a base system? A base system is a number of insect digits a system of counting allows to represent numbers. For example, if you are working in a base 2 system, no number is going to be what? Up to 2. So every number is going to be less than 2, but it must not be negative. So for base 2, we have 0 and 1. For base 5, all the number must be less than 5. 0, 1, 2, 3, 4. Our normal base system, which is base 10, our normal base system is base 10. That's from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and if you want to represent a number that is more than 9 in our number base system, we have to start combining this number. We can't have a single number for 15. It's not possible. We are going to have 10, 1, and what? 5. So that's what I mean by number based system. So let's go to calculation. So we want to convert a number from base 10 to any other base. What we do is that the base we want to convert to, we use that number to divide repeatedly. So for 35 to base what? To base 2 now, 35. How many 2 are going to see in 2? That's 1, number 1. 3 and 15, that's 7. That's 7, 14, that's number 1. How many 2 are you going to see in 17? That is 8. 2 times 8 is 16, that's number 1. How many 2 are you going to see in 8? That is 4. 2 times 4 is 8, that is remainder 0. How many 2 are you going to see in 4? That is 2. 2 times 2 is 4, that is remainder 0. How many 2 are you going to see in 2? That is 1. 2 times 1 is 2, that is remainder 0. How many 2 are you going to see in 1? It's not possible. So you have 0, remainder the 1. So you take it from the bottom to the top. So our answer is going to be 1, 0, 0, 0, 1, 1, base 2. So the number is now written as string of 0 and what? And 1, which is base 2. So let's go to the next one. What if you want to convert from one base to base 10? What we did earlier is from base 10 to any base. We want to convert from one base to base 10. How do we do it? We have two ways to do this. We can use the method of exponent. That's what we are going to explain first. So what you do is you want to convert this 241 base 5 to base 10. So I'll first of all write all the base on each number. 5, 5, 5. Then I will label from 0. I will give them power from 0. 0, 1, 2. Then I can now multiply and sum them up. 5 raised to power 2 is 25. That's 25 times 2. 25 times 2 is 50. Plus 5 raised to power 1 is 5. 5 times 4 is 20. Plus 5 raised to power 0 is 1. 1 times 1 is 1. So our answer is 71 in base 10. That is using the exponent method. What about if we want to use the multiple method? We can also do that. We start from the unit number. We give the unit number 1. So we'll now be using our base to multiply each one. 5 times 1, we use 5 to multiply this one, you get what? 5. We use 5 to multiply this 5, you get what? 25. So then we can now multiply and add. 25 times 2, that is 50. 5 times 4, that is 20. Plus 1 times 1, that is 1. That is 71. So the purpose of this is for students that are not very good with exponent, and sometimes they make mistakes. I've seen a student who wrote 5 raised to power 2 and wrote it as 10 instead of 25. That means the person did 5 times 2. Whereas 5 raised to power 2 is 5 times 5. Let's go to the next one. Now, if you want to convert from one base to another, you have to convert to base 10 first. Okay, let's convert 72 base 6 to a number in base 3. So I'm going to convert 72. I'm going to use that my second method using multiple. I want to convert to base 6. So I'll give the first number 1. Then I'll start multiplying by 6. 6 times 1, that is 6. So what do? 6 times 7 is 42 plus 1 times 2 is 2. So it is 44 base 10. So I cannot convert from base 10 to base what? 3. So we now have 44 to 3. So how many 3 are going to see in 4? We're going to find 1, with that 1. How many 3 are going to see in 14? That's 4. That's 12. Remainder 2. How many 3 are going to see in 14? That is 4. Then 4 is 12. That's remainder 2. How many 3 are going to see in 4? That is 1. 3 times 1 is 3. That is remainder 1. How many 3 are you going to see in 1? It's not possible. That is 0. Remember the 1 itself. So take it from bottom to the top. We have 1, 1, 2, 2, base what? Base 3. You can see. To convert to one base to another, you have to convert to base 10 first. So let's go. Now, how do you carry out addition? There are 2 laws that you must remember. When you add, the no number should be bigger than the base. And when you are subtracting, whatever you borrow, when you come to empower a number, you borrow from a number, the number will become the base. As if you are going to add the base to the number. Now, let's try this. 0 plus 1 is 1. It's not up to 4. We'll write it down. 2 plus 3 is 5. So, if you do this is 5. How many 4 are you going to see in 5? I'm going to convert. I cannot write 5 down because 5 is bigger than 4. How many 4 are you going to see in 5? You are going to see 1 remainder what? 1. That's 1, 1. I put 1 here. I keep what? 1. 1 plus 3 is what? 4. Plus 3 is what? 7. So I can write 7. So I will change 7 to base 4. So how many 4 am I going to see in 7? That is 1. Remainder what? 3. So I write 3 down and take the 1 to the next one. How many? 1 plus 1 is 2. 2 plus 2 is 4. And how many? I want to convert 4. I cannot write 4 down because 4 is the base is 4. No number should be up to 4. So I'll convert 4 to base what? 4. That's going to be how many 4 are going to say 4? That is 1. Remember 0. That is 1, 0. You see, this is very easy. Instead of doing it continuously like that, that's a very fast way to do it. If not, I'll still have to come here and do how many 4? 4 in 4. That's 4, 1. Remainder 0. Then I'll come and say 4. How many 4 I'm going to see here? 0. Remainder 1. I'll take it up. That's 1, 0. So you know, if a number that I want to convert is the same as the base, it's going to be 1, 0. If it's more than the base, it's going to be 1, 1. 1 more than the base, 1, 1. If it is 2 more than the base, it's going to be 1, 2. Just like that. Now let's look at it. We want to subtract this. 3 minus 1 is what? 2. Then 2 minus 3 is not possible. So what do? You borrow 1 from this number. When you borrow 1 from this number becomes 0. The number that you borrow becomes the base. So the base will come to empower this. 6 plus 2 is what? 8. 8 minus 3 is 5. Now, 0 minus 5, that's not also possible. You borrow 1 from here, this one becomes 4. What you borrow becomes 6. 6 plus 0 is 6. 6 minus 5 is 1. Then 4 minus 3 is 1. So our answer is 1152 base 6. Now, look at this. This operation is already carried out. They just want us to find what x is and what y is. Okay, let's do our own subtraction. 3 minus 4, that's not possible. I borrow from here. This one becomes 3. And this one becomes, the one I borrow comes there and become 5. If I will empower the 3, 5 plus 3, that is 8. 8 minus 4, that is 4. So that is right. 3 minus x, we don't know what x is. Let's borrow number here, 1 here. We have what? This one is left with 1. The one that we borrow becomes 5 to empower this 3. 5 plus 3 is what? 8. 8 minus x give 4. 8 minus a number give us 4. That number must be 4. So x is 4. So we continue. 1 minus 3 is not possible. What do? We borrow from here. This one becomes 3. The one that we borrow will become what? 5. Become the base. So 5 times 5 plus 1 is 6. 6 minus 3 is 3. I think that 3 is 5. 3 minus 1 is what? 2. So our x is 4. Our y is what? 2. Now, we want to look at this one. We want to multiply. This is base. I said the 7 is base 10 because it's not given a base. It means it's base 10. If the base is not written, it means it is base 10. We can do it directly. 7 times 5 is what? 35. Okay, let's do that. 35. So convert to base 6. How many 6 are you going to see in 35? That's going to be 5. Remember what? 5. That's 5, 5. I write 5. I keep the 5 there. 7 times 2 is 14 plus the 5. That's 19. So how many? I want to convert this one to base 6. How many 6 am I going to see in 18? That is 3. 6 times 3, 18. Remember 1. That is 3, 1. 3, 1 is 5. What if we are not sure of what to do? I'll just say, okay, let me convert this one to base 6 before multiplying. You see, have your answer correctly. Now, if you convert 7 to base 6, this 7 to base 6, how many 6 are going to say 7? 1, remember 1. You're going to get 11. So that's 11 base 6. Now, let's multiply. 1 times 1, 1 times 5, 5. 1 times 2, 2. 1 times 5, 5. 1 times 2, 2. Now, 5 plus nothing, 5. 2 plus 5 is 7. We cannot write it down. So we change it to what? Base 6. 6, how many are going to 7? 1, remember 1. So we're going to write 1 here. So the 1, we bring it here. 1 plus 2 is 3. It's less than the 6. You write it down. 3, 1, 5 base 6. Check what you get earlier. 3, 1, 5 is 6. So this one is also 3, 1, 5 is 6. So how do you carry out division? For division, you must convert both of them to what? Base 10. From what I've taught you, convert this to base 10, you get 27. Make sure you try that. Convert this to base 10, you get 3. So when you divide them, when you divide this, 27 divided by 3, you get 9. So 9 is in base 10, don't forget. But your answer is supposed to be in base 2. So you cannot convert the 9 to what? Base 2. How do you convert 9 to base 2? Let's do that. 2 in 9, that is 4. Plus 4, 8, give me that 1. 2 in 4, that is 2. 2 times 2 is 4, that is remainder 0. 2 in 2, that is 1. 2 times 1, 2, that is remainder 0. 2 in 1, 0. 2 cannot go in 1, that's 0. Remember the 1 itself. Take it off, we have 1, 0, 0. Base what? Base 2. So to divide, the best thing to do is to convert to both of them to base 10, then divide and convert that to your answer. Now, we want to look at how to convert decimal number. We have been converting just whole number. We want to convert number with fractional part. Now, convert 11.25 base 10 to a number in base 2. The whole number part, 11 base 10. We are going to convert that one the normal way, our repeated division. 2 here, 5, times 5, 10, remainder 1. 2 here, 2. 2 times 2, 4, remainder 1. 2 here, 1. 2 times 1, 2, remainder 0. 2 here, 0, remainder what? 1. Taking from top to the bottom, 1, 0, 1, 1. Then, we did repeated multiplication here. So we repeated division. For the fractional part, we are going to do repeated multiplication. That's just the opposite of that. 2 times 5 is what? 10. Remainder 1. 2 times 2, 4 plus the 1, 5. You can see this one gives us 0.00. So we bring the 0 out here. Whatever that we have in the O part, we bring it out. So we continue. 2 times 0 is 0. 2 times 5, 10. Remember 1. 2 times 0, 0 plus the 1, 1. So we take the 1 out also. So we have 1. So when you take the 1 out, this place will become 0.00. So there's no need to continue the multiplication. You can see the other one here, we pick from the top to the bottom. This one I'm going to pick from this one here, we pick from the bottom to the top. This one here, we are going to pick from the top to the bottom. Just the opposite of what we did up there. So our answer is going to be 1011.01 base what? 2. The last but not the least, let's quickly do this. We want to convert 203.14 base 5 to a number in base 10. We're going to use that our multiple method. Very easy. This is the unit. I put 1 on it. The base is 5. I'll keep on multiplying by 5. 5 times 1, 5. 5 times 5, 25. You see, this one is 1. So this part, the first part of this is going to be 1 over 5. This place is 5. This place is going to be 1 over 5. This place is 25. This place is going to be 1 over 25. So now let's multiply. 25 times 2, that is 50. Plus 5 times 0, 0. 1 times 3, 3. Plus 1 times 1 over 5 times 1, 1 over 5. 4 times 1 over 25 times 4. 4 over 25. So when we add it up, we get 53 whole number. Yeah, let's do the first add of the fraction. 25 divided by 5, that's 5. 5 times 1, 5. 25 divided by 25, that is 1. 1 times 4, 4. So our answer is 53 whole number, 9 over 25. So in this one, 10. Don't forget, you can write this one with point also. You can be 53 point something. So when you put 9 over 25, whatever you get, point, this is that, you can put it at the back there. So thank you. Make sure if the video is too fast, you can slow down the video and you can send me your questions. Thank you very much.